we consider introducing yourself?
Yeah, really quick. My name's Sean Anderson. I'm in the DIU Autonomy portfolio. I was prior Air Force. I'm the only one I think on the stage here that isn't an Air Force member currently. But I predominantly work in the small space for small UAS, including Blue UAS and collaborative autonomy for small UAS.
Hey y'all, I'm Major Vic Lopez, Salsa. I'm a Reaper pilot in the Air Force. Spent 3 years helping stand up the Artificial Intelligence Accelerator up at MIT, working specifically small UAS, robotics, autonomy, human machine teaming, and the difficulties there. Got to work with Sean while he was over at DIU building some products for some of the special operations community. Now at AFWERX, working very similar things, mostly machine learning pipelines, because the one thing that robots need in order to be good robots is to understand their environment. The best way to do that usually is through machine learning models. And so helping AFWERX and some of our operational communities put that into production.
Kristina Botelho. I am a contracting officer and agreements officer for the Air Force. I wear a number of different hats, supporting a number of different groups, but my primary support right now is with AFWERX Autonomy, executing contracts, helping them with their acquisition strategies, and just trying to find the fastest ways to get to deployment.
Gansburger, I'm a JTAC by trade, former DIU actually, and got my teeth wet in innovation, and through that kind of became a software evangelist. So now I'm a software manager for AFWERX Prime, and trying to enable being able to do a lot of this autonomy and AI in a way that we can get certified and assurance and ATOs and rapidly actually field to the warfighter.
So let's see, we can do this a variety of ways. I thought maybe if you share a story or two from each on your experiences, and then maybe we can have some reactions or questions from the audience, maybe.
Yeah, absolutely. Getting into a little bit more detail, so I work on the AI for Small Unit Maneuver program at DIU, and it's one of the several programs that we have working with small UAS, but it actually combines like a series of different efforts. And kind of critical to that program is actually a series of different interfaces that are either government specified or are essentially conventional that came out of the commercial space that we use to help drones that come from the commercial space work with government-owned software. And that specifying those interfaces and kind of enforcing those has been both a very big challenge for our team, but it's also been essential to making sure that we can bring in new technologies. I actually kind of have a question for you, ma'am, if I can put you in the hot seat, which is, we talked about heterogeneous teaming and collaborative autonomy a little bit, but one of our big issues, I think, is how do we actually manage commercial success when we have varying basically data rights to the collaborative architectures, where you may have some commercial architectures out there that offer a lot of opportunity. We have government-owned architectures and even potentially open source architectures that may provide an opportunity for us to really get after the collaborative autonomy issue.
So are you asking a question about data rights primarily?
Primarily it is, yeah, and I think that's kind of something that gets interesting to this audience, where you have a lot of commercial contenders who want to participate in that space.
So you know, I know this is a hard thing to say, but you know, somebody has to aggregate all the data, and that somebody has to be the government at the end of the day. Now, this is not to say that we don't value the creation of that data, right? So at the end of the day, it's a business arrangement, but it cannot be the case that data exists that is critical for training of systems that we depend on, that government does not have access to. Because when that happens, we then end up with how can I say, you end up with situations like, so Phil Dawn here from C3AI and put you in the hotspot. So, the F-35 collects a lot of data. Government doesn't have access to it. So what do? We put an extra box on the F-35 so that we can get some data back out of it. So that's not a good situation to be in. But at the same time, we need to recognize that, the creator of that system, whatever it happens to be, they're in business for a reason, right? So we need to be very reasonable and value data, but at the same time, we do absolutely need to have access to it in mind.
Thank you, and to maybe elaborate a little bit more on that story, and I think that has come up in many of the projects that I've worked on, where even commercial companies, there are some that are in the business of labeling data, and there's some that are in that business that don't want to be, right? That would prefer that the government was working on that so that they could essentially just deal with clean data and not have to dirty their hands with the messy and unlabeled data that we tend to fork over to them. So I see that as one of the challenges that we're trying to overcome among all those data rights challenges. Salsa, your turn.
Ma'am, I think this is a good story. You've heard me tell it, I think, 3 or 4 times now. I think when we met this morning, you said, I know you. Yes, ma'am, it's from the story, right? So it's the same story every time. So it was a few years back. I was on an op, and I had a great opportunity. So I was flying live combat missions downrange, and had an opportunity to work with some great engineers from Air Force Research Labs. Happened to be a subcontractor. They came out and they had said, hey, we have this box. It's been we have the authority to operate at the IL5 and secret level. That's amazing. Authority to operate is really hard to get, especially for hardware. It's like, okay, that hardware, what does it have in it? Hey, it has GPUs. It's like, oh man, I got really excited. Maybe some of you guys know where we're going with this from the AI perspective. From a data perspective, we had to figure out how to get data off of the, in this case, an MQ-9, it's not an F-35. Take the images, label them, train a model, and then deploy it back out to the airmen. And the one thing that we've done, I think, from the intelligence community and the great the global war on terror, we realized that we didn't have to send everybody to the front, right? Our intelligence folks didn't actually need to sit with us in the top-down range. They could be stateside. And that saves us so much money because we had the connectivity. And in doing so, we made massive supercomputers on our intelligence community with really exquisite models that are running on lots of compute. The problem, I think, for our next fight is going to be a disconnected fight, right? Where now I'm going to have to push all of that forward, which means I'm going to have less bandwidth, a lot of data, not a lot of people, and I need to be able to communicate back to the stateside folks who probably are going to have a lot more capacity, but also do that quickly at the front. And so what we did during this operation is we took the data off the MQ-9, a random troop, and this happens over and over again in the Air Force, random troop comes up to us and they're like, hey, you should go talk to the nerds in the back, because I hear you're nerdy. So he comes and he talks to the nerds in the back, and we're literally in the back garage, right, like tinkering on this Linux box. And then I tell him what we're doing, and I was like, it'd be really great. You know, we've been pulling stuff by hand via hard drive in this manual process to get it off the MQ-9. I think we have some like actual models now after about a day of training a model, but I have no way to show it back to the operator's time. Like, because I can't connect the cockpit to this computer. That goes against authority to connect, right? Another major policy hurdle. And this airman in the back said he was a comm troop. So he used to be a comm troop, and now he was doing like deployment stuff because he needed to promote. He was in the guard, and he had to move laterally. It was in the guard. You might know what that's looking for. So he's like, I think I have a solution. I have 3 switches, 2 different firewalls, an HDMI cable, and if I can just give you the cable, dude, you're good to go. And so we had to think, well, how do I actually move the data now into this computer? And the story that Dr. Coleman heard was we realized, well, you know what, Twitch streamers online do this all the time. So I took the government purchase card, I went out to Best Buy, I stood in line in front of a kid who was waiting on his PS5, and I bought a very critical piece of $100 hardware to go plug into this Linux box so that I could take an HDMI cable and actually run models live. And for the first time in 20 years in the global war on terror and now in the Great Power Competition, in this operators had a live view of models running next to their cockpit. And they had never had that before because we had always pushed it back. But having a very small amount of compute, having an API, in this case it happened to be HDMI, it doesn't have to be fancy at all, right? An HDMI cable that the commercial sector built for us, and a Twitch streaming stick, and a Linux box was all that it took in order for us to actually move that to the front. Now, I didn't touch MQ-9's General Atomics' proprietary hardware. I didn't touch their proprietary software because they do that well. That's the licensing fee that works, right? You guys can build the airplanes, and sometimes you build the software that's miles ahead of us. But every once in a while, I need a government API that can take that airplane and can take Linux that's open source, and I can put it together and make something special out of it. But I'm going to have to trust that vendor, or it might be the F-35 vendor, to make the better airplanes tomorrow. So that's my question.
This is a story that keeps on giving, so I'm glad to keep on telling.
So I don't have any exciting Reaper stories or Best Buy. I do what Dr. Coleman very astutely described as the really hard and boring stuff with acquisitions. But my innovation story started before them. It started with Kessel Run. and standing up the first software lab for the entire Air Force. We actually did that in 72 hours, the very first Air Force lab, from RFP to award, because we had to get it done in order to secure that space. So it started years ago, and from their backgrounds, you can see I don't actually have acquisition support when I'm doing these contracts. So I have to be really smart about what I ask of them, as well as how to make it as streamlined as possible. So they came and they asked me to support the autonomy for the entire Air Force, set up those contracts. And we were able to set up a number of IDIQs, $100 million IDIQs, each of them, and we can make award in days instead of weeks or months at this time, just because we were able to set it up in such a way that as soon as you come to us and tell us your problem, I mean, the long pull right now is getting the funding document, so.
So this is acquisition magic. I mean, you see it right here.
Yeah, you are magic. I would say, for me, one of the more eye-opening things was going from traditional acquisitions at a MAGCOM and being embedded in, it was actually a prime, and my eyes were open to the fact that really the problem wasn't the primes, it wasn't vendors, it was how the government was going about buying software. Because as an embed, I literally worked 2 projects at once, one upstairs, one downstairs in the same company. One was being agile managed by DARPA and had 1/8 the budget and 1/6 the amount of people working on it. Then the one downstairs was managed by a traditional PEO. That one we spent millions and millions of dollars and it never made it through OT. Just a complete loss of government money. The one upstairs is still in use 10 years later. It was a total success. And so that kind of was my passion to how do we tap into the things that work and make that our pathway forward. And that led me to DIU, led me to working with the folks that kicked off Kessel Run. And now I'm looking at AI ML has so many more vast data requirements than just a couple of companies. And as we reach out, there's also the fact that, 1976, I think was the last time the federal government was the leader in R&D. It's the commercial sector. So how do we leverage these things where there's billions and billions in IRAD that's competitive and get that rapidly turned into the government using the smarter policies? Because Dr. Coleman said it best, I as a JTAC, as a SOF operator, the last 20 years in the global war on terror, we adapted our TDP to coin, but we never adapted acquisitions. The whole military is still a Cold War acquisitions model. And if we're going to continue to use that model for software, we're never going to get anything innovative, because that's not how the real world really works. So tapping into that capital and tapping into the commercial sector, I think there's a ton of opportunity there, and I'm just glad to be part of it.
Okay, so we lack a fearless leader here, so I'm going to pretend to be that. Any questions or comments, contributions from the audience?
Not everybody all at once.
Well, I've been known to pick on people. I used to be a professor, right? So I would ask questions like this, and it would be crickets. So then, how about you? So I'm going to pick on Phil. Go.
This is actually a genuine cold call. So I've listened to you speaking a couple of times, and everyone can hear me. So I think the audience is fairly familiar with the different problems from the hybrid industrial base interacting with DoD and the acquisitions process. Specifically for this context, when we want to understand and leverage commercial industry for algorithms and such to help autonomous vehicles interoperate with each other. How do you guys imagine an ecosystem where on the commercial sector, especially if it's dual use, you're not incentivized to participate and collaborate with your competitors at scale, right? And so we've seen that over the last 10 years, specifically in software, where we throw this notion on CJAT2, but we rely on industry to build things and they're not incentivized to play with each other. Anyone for the panel?
We predicted this question. Like, this was literally what we discussed in the green room before he came out here. Someone's going to ask that. Yeah, and we even have complex opinions on it because it gets back to GPR and what the government is incentivized for versus what the private sector is incentivized for, and then also how we can structure contracts more beneficial to everybody. My policy on it is if it's dual use, I would rather incentivize the industry to keep competing and we maintain the interfaces like Sean was talking about, so that we can plug things in but invigorate the industry to compete against itself and lower my costs, lower my barriers. When we start worrying more about like data rights, especially for training models, is when it becomes something that's very military specific. And that doesn't mean I need to go to a prime. That just means I'm probably going to be looking more towards like a service-based contract where I'm more worried about retaining the rights because I'm going to have to maintain it myself.
It went into the audience. Yeah, I think to add on a little bit, it also means it behooves the government to really understand how you're building that software. So let's take robotics for a second. What are the main languages that everyone uses? ROS2 and MATLAB. And good old TCP/IP, all the internet, right? That's how we've been connecting lots of different things around the world for a really long time. Just like that HDMI in my story, right? These are not complex concepts. But we as the government need to understand that, well, if you as the private sector are likely going to start your idea with whatever is on GitHub today. Well, what's on GitHub today is ROS2 and MATLAB. If I make my interoperability protocol ROS2 or HTTP and just TCP over IP, well, you know how to build to that. And your robots are probably already speaking that language. So now if I have a government architecture, a government purpose rights software that's going to take your robots and put them with those robots, and I know that you can speak TCP/IP and they can speak ROS, my GPR just needs to be able to accept that. But that requires me to understand what you are building. And now it becomes really easy for you to say, okay, I'm going to give you this robot, and I give you a set of things that I expect. And so DIU has done a great job here with RAS-A, the Robotic Autonomous Systems Air architecture interoperability protocol. That isn't a brand new standard. We're not reinventing the wheel. We're not taking your HDMI cable and saying I need you to switch 6 of the wires in that thing. I'm saying, no, I'm going to take your MavLink and your ROS, and this is what I expect to hear from your MavLink and your ROS. And now I get to talk to you. And by the way, I can make your robot talk over there by sending it through my router.
Oh, just a couple more things that I do. I constantly talk about in that small space. RAS-A is one of those things. But they're all very familiar and honestly commercially based because commercial is leading the space thoroughly, whether it's RAS-A as an example, MISB, 0601, 0903 for KLB, RTSP, streaming protocols. But the key piece of all of those is what it creates for you as a commercial company that is disincentivized, essentially, to have your peers essentially replicate your capability. But then also, it is one of those things that what you really want is to focus on a bespoke capability in an MVP format, right, and get to market and control that market, but not necessarily create this jack-of-all-trades capability. That's where I think the miss is that you need to, what we see is a lot of companies that can make a robot that does this specific thing incredibly well, and I want to take that robot and pair it with the other robot from another company that does a completely different thing very well. And sometimes to cross that bridge, an individual robotics company has to make everything from on-system software down to GCS software, or borrow open source GCS software and modify it, hand controllers that they have to make, and creating that severability so that you can essentially take hand controllers from other companies, is already what MavLink does, and what we're trying to do is take that a step further with essentially high-level government-owned architectures that augment that capability so that you can build bespoke autonomy on your system, which makes the most sense, and then that system gets augmented by other systems that don't compete with you.
Can I just ask you to expand on that MVP concept? So as we apply a commercial MVP kind of ideology, but one of the foundational aspects of that is that there's going to be a customer that we iterate with quickly. Commercial world, the customer is everybody that can access the app. Defense, obviously not the same. So how do y'all see AI, especially on just software side as opposed to autonomous systems or robotics? How do you see that iterating real time?
Copy. So DevOps of AI. This is my side. Hi. All right. As Dr. Coleman mentioned, with some of the problems that we have on some of our larger airframes of getting data out, in this case, in my case, right, it was like an airman in the back who realized he could route things over HDMI, right? That's how I got data out quickly. In I think the small UAS case, we need to figure out. I have a couple white papers on this of robotics first strategy for the DoD to think about, right? So what that means is robots are great. AI doesn't need to be your entire robot. We've been using autopilots and PID controllers for decades, right? If I need my airplane to go from here to there, I can do that in 1970, right? And we can still do that, and we should not make AI do that, right? There's no reason for a reinforcement learning algorithm trained on thousands of hours of GPUs to have an airplane fly straight and level from waypoint to waypoint, right? And small UAS companies know this, and they've been doing that for a while, using good old PID controllers. So with a robotic first strategy, you say, what is it that my robot wants to do? And what is the easiest way I can make my robot do that? And in doing so, I might be able to engage some high-level behaviors of follows, of tracking. But when you start breaking apart your robot, you say, okay, my robot needs a perception pipeline. Do we have a good non-AI perception pipeline that AI can't, that can be beat, or that can beat AI? And I don't think there is. The computer vision's really good now. We know how to do that. That's definitely going to need to be a DevOps AI ML ops option. I need to be able to pull the data off an RTSP stream, collect it at high quality, train, validate, and redeploy that model back to the robot over the air every hour, every minute, however long it takes the enemy to realize that they can get onto the other side of my detection curve. I need to be able to update that, which means that my software for that likely needs to be at the tactical level, not at the program office level, right? Because that's going to be up front, because they might not even have the communications to go back home like we did during the Great Power Competition. So I need to be able to enable that, just like I did in that MPI story. And then everything else, though, from your trajectory planner to the way that the robot interacts with each propeller or a gas motor, are all PID controllers, all heuristics. And that's okay, and you can use that. And if I'm just going to be taxiing out from an airport on a larger even airplane, that's probably all going to be heuristic based until I get in the air and I flip on the switch of, okay, this is the mission that I need you to do. And all that the autonomy is really just really good robotic software that opens up my aperture of what I used to be able to do with the system. In the same way that whenever I shoot my missile, I give it a very bounded box of operations that it can do and what I expect it to do based off of the software that I have already predefined there. All that a robot is doing the same thing, but I've expanded that box just by a little bit to allow it to operate. Does that answer your question?
Close enough.
Hey, quick question. From the commercial side, we look at how we sell and market. I usually go, I don't need this. I'm a retired sergeant major. When we look at, one of the models that's never worked is when you have a channel and a direct market, especially in sales. When we look at the government, sometimes we see not only, we see both things. The government is also building things, but at the same time, it's asking us to deliver. And so, when you look at some of the stuff the government's built on its own without commercial, I would say some of it has been subpar. But when you go approach a customer and you find out, it's like, wow, and then you got contractors that have already been hired to hire these things, and you build a culture of resistance, a resistance to change, resistance to evolution. So how do you propose to change that? Because on the outside, and I'm also a retired military guy, that to me has been a defense contractor for 23 years. Has been one of the largest obstacle to evolution within the military. And so I'd like to get your thoughts on that.
So honestly, you have to be real pushy and force it. That's what I've done over the years. I've luckily built a reputation where people listen a lot quicker now. But I can be relentless when I know that what we're doing is not the right thing for not only the warfighter, but the taxpayer as well. So it really is something that it's top down. I think leadership has to support that change. They have to know that they're safe in making these decisions and going out on a limb to do things differently. As well as the education from the bottom up. Contracting officers, program managers, they need to understand what all the options available to them are. Our market research methods are antiquated. They don't get us what we need. They're basically used to check a box for a presentation you have to give to some PEO to decide NAICS code and contract type. There's no real value in it. So market intelligence is a huge point where contracting and program managers have to really get better at scanning the market and finding those solutions. They have to be open to new solutions and not just looking for their solution. And then just teaching them data rights, intellectual property, SIPR-SITR programs. It's not in the FAR and the DFAR, so your contracting officers they're not familiar with it because they weren't told to learn it. So I provide training throughout the entire Air Force on these types of things, and I'm surprised at how many people, even now with how open topic has just exploded over the years, people still have no idea how to execute their own SIPR-SITRs in their offices. So it's really education from the bottom up as well as leadership support from the top.
We have time for one more.
Thank you very much. I probably also don't need this because I've been told I'm a very loud talker. But a question that I have is around trusted autonomy. And I think it was Mr. Salsa that had said something to the effect of using PID controllers and using a series of automation and robotic automation, and those have worked since the 70s and they do work really well. So what is trusted autonomy if we're just expanding the box that you said? What is trusted autonomy then? Because it sounds like what we have is a series of command and control systems that are following PID guidance. You know, these are just heuristics that we've chained together, and now we've got these complex MLOps pipelines dumping data back into to what end? What is trusted autonomy then?
So maybe I can have a stab at that, and then Salsa can follow up. So, you know, typically, you know, with a complex system, and of course you've been flying airplanes, you know, and with autonomy for a long time, with automation, I should say, for a long time. How did we do that? Well, complex systems, you test them up to the wazoo, right? And why do we do that? Because we know that we're going to put this deterministic.
That's the music.
I know, operators, difficult. We test the systems, we expect them to be deterministic, and then we put them in a non-deterministic environment. So, you know, for whatever the environment throws at them, we know roughly how they're going to behave. So you create the safety envelope. Well, with a machine learning system, a truly autonomous system, you no longer have determinism in the middle. So now you have two sources of uncertainty, inside the system and outside. So now you're done. You know, all the approaches that worked, you know, in the first generation no longer work. So you really have to think very differently about how you go about establishing some trust. And I don't know the answer. I hope that the York, for example, will produce some answers. But I know that if I build a little, I test a little, and I fail a little, that gives me more confidence. And then I can begin to iterate on that, right? So I need to have a modicum of trust so that I can deploy it and I can learn more. So I think that's a kind of an obvious way of changing the paradigm.
Thank you, ma'am. So quickly, I'll split this into 3 seconds. There is reinforcement learning, there is traditional supervised, and then I'm going to go really quickly into a brand new thing that we just tested because it's super exciting. It's called a liquid neural network. Okay, so reinforcement learning. Awesome. So reinforcement learning, right? This is, I'm going to give you the airplane a game. We've done this a lot on Visto. We've done it on Venom. And we're going to put it through millions of paces. In the first few 100,000 iterations, the plane has no idea what it's doing. It's just going crazy and has no idea. But you're like, okay, I'm going to give you a cookie every time you do what I want you to do. In this case, it might be like, you know, taking out the other airplane in a DCA or OCA type attack, right? So defensive counter air, offensive counter air. That is, once that model is trained, it is deterministic, but it is non-heuristic, right? In the sense that you don't know if you change an input how the airplane will respond. Deterministic, but non-heuristic. But given the same inputs, it will always do the same thing. Okay, so that is really hard, as Dr. Coleman mentioned. One thing that we're doing within Autonomy Prime is to put a regulator in the side. So we actually have a regulator that it's called CASE, and that system, our reinforcement learning agent, we'll send a command to the case autopilot. The case will then decide whether or not that is within the envelope. And then if it is not within the envelope, it will ignore that command. And if it gets outside of the envelope, it'll actually kick on its own PID controller to return it back to a safe location. Right? So in that way, we have layered our autonomy and our robotic software to ensure that we're always doing the right thing. All right, supervised learning. Now we're talking models for just normal things. And I need to trust that my large language model is going to give me the right information. It's not going to hallucinate, right? There's lots of ways to do this that is written in literature, and we can kind of figure out and validate and use new techniques like reinforcement learning with human feedback in order to kind of give that vote up or down. And then lastly, liquid neural networks. So neural networks, if you guys don't know, are thousands of nodes, hundreds of thousands of nodes. And whenever they fire, you're just figuring out, is that node on or off? And somehow, through the math, we haven't quite figured out how to make this into an actual equation yet. That's why we use the neural networks. That spits out the right answer. It's really cool. But it's all simple algebra. Mx plus b times like a little tiny function. Really, really simple. Just a lot of it. In liquid neural networks, what we found is if we add more intricacy to the node, we can go from 100,000 nodes to 19 nodes. Just a couple months ago, back in September, we flew a liquid neural network on an F-16. And that is actually up now for a Collier Award with finalists. It's a huge deal, right? Neil Armstrong was a previous recipient of the Collier Award. But that gives us insight into each node, and now I can fine-tune based off of the nodes that are firing what went wrong in my training data set and how to go and fix it, because I can diagnose it. Hopefully that answers.